Hi, this is Thomas. Welcome to Calculus. We recently learned about calculating the area under a curve using the fundamental theorem of calculus, and today we're going to learn how to calculate the area between two curves using the same concept. The notation for the concept is that area is the integral from a particular range a to b of the difference between two functions, f of x and g of x, with respect to x. And based on rules of integration, this is the same as the integral from a to b for f of x with respect to x, minus the integral from a to b of g of x with respect to x. So we're going to integrate two functions, calculate the definite integral values, subtract to get the area between the two functions. Let's analyze the two functions. F of x equals 3 times sine of x, and g of x equals sine of x. And let's check these curves in the Desmos graphing software to make sure we have them in the right order. We want the higher curve minus the lower curve. And these are our graphs. The blue curve is y equals 3 times sine of x. That's clearly the higher curve. Below that is the red curve, y equals sine of x. I've also marked off x equals pi because the range of our first calculation is going to be from 0 to pi on the x-axis, the area between these two functions from 0 to pi. So for the range 0 to pi, our first calculation, we're going to have the integral from 0 to pi of the difference between 3 times sine of x and sine of x with respect to x. Now, sometimes it's more effective to split the integer and calculate the integral of the first function and calculate the integral of the second function and then subtract those two integrals. But in this case, we can simplify more easily by going directly to the difference between 3 sine of x and sine of x. In other words, I'll take the integral from 0 to pi of 2 sine x with respect to x. The integral of sine of x is negative cosine of x. And I'll keep the multiple of 2. I have negative 2 cosine x from 0 to pi. And my valuation will be negative 2 times cosine pi minus negative 2 times cosine 0. Cosine of pi is negative 1 times negative 2 is positive 2 minus negative 2 times cosine 0. Cosine of 0 is 1 times negative 2 is negative 2 minus negative 2 is plus 2. So I'm adding 2 to get to 2 plus 2 is 4 units squared. The area between the curves 3 sine x and sine x from 0 to pi is 4 units squared. Now let's look at the same two curves on a longer interval, 0 to 2 pi. And our integral is the integral from 0 to 2 pi for 3 sine x minus sine x with respect to x. Now let's go over to Desmos, take a look at what these two curves look like on the longer interval. Here in Desmos, I've zoomed out just a bit. We see the same two curves. With the zoom out, we can now see the range from 0 to 2 pi. Notice I've changed my vertical line to x equals 2 pi. So we're looking for the area between the two curves from 0 to 2 pi. Notice what happens at pi. What happens at pi is that the curves shift. Now from pi to 2 pi, the curve y equals sine of x is above the curve y equals 3 sine of x. This means that we're going to need to do two calculations. One will be the area between the two curves from 0 to pi, which we've already calculated. The other will be the area between the two curves from pi to 2 pi as a separate calculation because the higher curve is now sine of x. So we'll need to switch the subtraction order for the second calculation to arrive at the accurate combined area between the two curves from pi to 2 pi. So let's go back to the whiteboard and complete the calculation. So I'll split my integration. I know from 0 to pi that I have a value which I've calculated in the center of the screen as 4 units squared. Now what I need is my calculation from pi to 2 pi. And in this case, I'm going to reverse the order of the function. Sine of x minus 3 sine of x with respect to x. And again, the reversal is because on this interval, from pi to 2 pi, the higher curve is sine of x. So I'm now integrating from pi to 2 pi. Negative 2 sine x with respect to x. And my integral for negative sine of x is cosine. So I'll have a positive cosine x. I'll keep the multiple of 2 in front, and I'll evaluate from pi to 2 pi. And the calculations are 2 times cosine of 2 pi minus 2 times cosine of pi. Cosine of 2 pi is 1, and 2 times 1 is 2. Then cosine of pi is negative 1 times 2 is negative 2 minus negative 2 is plus 2. So I will have 2 plus 2 to sum to 4 units squared. And the combined area from 0 to 2 pi is our first calculation of 4 plus our second calculation of 4 to combine to a total of 8 units squared. That's the area between the curves 3 sine x and sine x from 0 to 2 pi, noting that the curves switch places, thus we have 2 separate area calculations to arrive at our final value. If you were to integrate from 0 to 2 pi without splitting in the middle to acknowledge the change in order of the functions, your final value would end up being 0. Let's look again at our graph. If we don't switch the order of the functions in the interval pi to 2 pi, and we subtract 3 sine x, which is the lower curve, minus sine x, which is the higher curve, we end up with the negative area value. And the negative area value in this particular example would exactly offset the positive area value from 0 to pi. So without switching the order for the interval pi to 2 pi, you end up with an area of 0. And as we've confirmed, the correct calculation for the area between the curves for the interval is 8 units squared. This concludes the lesson on using the fundamental theorem of calculus to calculate the area between two functions. Thanks for watching, and I'll see you in the next lesson.